Hi everyone, we are Team Black Panther Party, and I'm Daryl, and today we'll be walking you through our approach to forecasting intraday contact center demand for August 2025. So let's start with the problem itself and how we chose to frame it. So the goal was to forecast call volume, handle time, and abandon rate at the 30-minute interval level across four portfolios for August, which is nearly 6,000 predictions. And this matters because if you were to staff by daily averages, you would miss peak demands, which would just lead to longer wait times and higher abandon rates. So we started by reframing this as two separate problems. So first, how big is the day? So predicting the daily levels. And then second, when does the activity happen within the day? So finding the shape of each day and then allocating it across 48 intervals. And those require different features. So instead of forcing one model to do both, we split the problem. So here's the full pipeline. So data flows through a shared prep layer and then splits into a daily model and an interval model. And those outputs are then combined in a final step to keep everything consistent. And the idea here is modularity, so each part can be improved independently. Now we'll delve into the data because before modeling anything, we had to understand what the data actually looked like. We were given three data sets: daily data from January 2024 to August 2025, interval data from April to June 2025, and staffing data for 2025. And the main limitation is that the interval data only covers 3 months, which makes forecasting August more challenging. So for data prep, we found two key issues during auditing. First, the interval totals didn't match the daily totals, and this was because there were missing intervals in the data. The missingness was systematic, as you can see here, so we imputed those using day of week and slot medians instead of dropping them. And second, we realized the staffing data only covered 2025, so we filled in 2024 using the day of week medians, assuming the schedules are relatively stable year to year, and then we integrated that into the daily sheet. And from there, we moved into feature engineering and feature selection. So we built separate feature sets for each model since they solve different problems. The daily model uses lag features, staffing, holiday, and calendar effects to capture long-term trends. And the interval model is simpler. It focuses on time-based features like interval, day of week, and daily call volume to anchor the shape to the correct scale, and then plus a peak hour indicator. So we used feature importance to validate our inputs. For daily CCT, recent lags dominate, showing that handle time is highly driven by recent history. Oddly enough, staffing also ranks very lowly, which is a bit counterintuitive. But for intraday call volume, slot index, and peak hour dominate, which confirms that time of day is really what's driving the shape here. Now for the modeling decisions. So here we have the overall approach. So August daily call volume is provided, so we don't predict it. We just use it as an anchor. Daily CCT is where we use machine learning. Daily abandon rate is just rule-based using a blend of recent history and same-day week prior August behavior. And at the interval level, call volume uses machine learning plus day of week profiles, while CCT and abandon rate uses historical profiles scaled to the predicted daily level. The key here is that not every target is equally modelable. So daily CCT is smooth and predictable, so machine learning works well there. Intraday CCT is much noisier, so machine learning adds more variance than signal, so profiles work better there. And abandon rate, as you can see, is highly right skewed. So most days are low, but rare spikes really drive the impact. So instead of overfitting the noise, we used profiles to capture when high abandoned windows happen without trying to predict every spike exactly. For evaluation, the daily CCT model was trained through June 2025 and back tested on July. And the intraday call volume we trained on April and May and then tested on June, which was the closest available analog to August. And we recognize that June may not fully represent late summer patterns, but given the data constraints, this was the strongest and most realistic setup. So we ended up testing 4 algorithms for each model. For daily CCT, all tree-based models performed similarly, around 2% MAPE, and we ended up choosing histogram gradient boosting because it supports quantile loss, letting us add a slight upward bias, and that matters because underpredicting CCT leads to understaffing. And for intraday call volume, linear regression failed at 135% MAPE, showing the patterns are highly nonlinear. And the histogram gradient boosting plus extra trees ensemble performed best at 18.6%, so that became our final model. And then we blended our models with historical baselines. So for CCT, a 70-30 machine learning plus historical blend matched 50-50 performance while trusting the trained model more, so we chose it for better generalization. And for intraday call volume, a 40-60 machine learning profile blend matched pure profile accuracy, but it was more stable. And you can see that most clearly in profile D, where adding machine learning improved performance. Here's the final CCT forecast across August, and you can kind of see the weekly patterns with CCT dropping on weekends across all portfolios. This shows the intraday call volume shaped by day of the week, and you can see a consistent peak around 2:30 p.m. across all days. And here are our forecast results. Putting it all together, we forecast just under 1.3 million total calls for August, with about 16,500 abandoned calls. So what does this actually mean for the business? So the real value comes from the 30-minute granularity. Staffing to daily averages means you miss the times that actually matter. And even with a rule-based approach, we still capture when high abandon risk occurs. And separating models by portfolio matters because each client has a different intraday pattern. With more time, we focused on three areas. First, adaptive blending that updates as new data comes in. Second, extending the pipeline to more portfolios. And third, getting more historical interval data, which is the biggest constraint on our current forecasts. And that's our system. Thank you guys for listening.